SPSS is a super easy software for data management and research. Today, I'm going to be showing you an easy way of using SPSS for any kind of research. Hi, and welcome to the SPSS for Research channel, where I help students and researchers learn how to use SPSS for scientific research. SPSS in 20 minutes is my second tutorial video on this channel. In my first video, link here, I show you a quick and easy step-by-step guide in installing the latest version of SPSS, which is SPSS 28, and for free. Well, for this video, I'm going to quickly get you up to speed with SPSS. So you will be going from zero to hero with SPSS in just 20 minutes. My name is Abdul Hakim, and I'm a public health physician and lecturer in the Department of Community Medicine, Ahmadu Bello University, Zaria, Nigeria. In this tutorial, I'll be covering the SPSS graphical user interface, creating variables in SPSS, entering data, analyzing and interpreting results, constructing charts, and saving your results. So what are we waiting for? Let's do this, shall we? Since this is the SPSS for Research channel, this tutorial is going to be practically as well as research oriented. And so I will be using a questionnaire which we developed from a small survey to show you how to get going very quickly. This survey was a quick survey meant to identify factors associated with hemoglobin levels among medical students in Ahmadu Bello University, Zaria. So we start by explaining the SPSS graphical user interface. For this tutorial, we are going to be using SPSS 28, which is the latest version of SPSS. But even if you have any other previous version, it is very similar and you can still follow along. The first thing for you to know is that SPSS has various windows. These windows allow you to interact with the different parts of the software. The two most important or popular windows are the data editor window and the variable editor window. So we start with the variable editor window, also called the variable view. All right, this is where you put your variables and its characteristics. Next off is the data editor window, looking very similar with the variable editor window, and is also known as the data view. Okay, the data view is meant for manual data entry. Standard data entry process will require you entering the variable characteristics in the variable view and then coming to the data view to enter appropriate data for each person, variable by variable. Okay, next off is the title bar. And the title bar is the first bar on the software and is usually carries the word untitled. When you see this, it means that your data is not yet saved. And as you know, saving is really important so you don't lose your important word. So the title bar shows the name of the file that is open. Once you save, the name of your file will appear on the title bar. And next off is the menu bar. And the menu bar is just directly below the title bar. It has tabs with several menu items in each of the tabs. You can access those menu items using the drop down. All right. The last aspect of the graphical user interface that you should know is the toolbar. In the toolbar, there are menu items that you ordinarily find in the menu bar. However, the ones that you find in the toolbar are the ones that are most frequently used, kind of like a quick access toolbar. So that's that for the graphical user interface. So next off, we are going to be talking about creating variables. As earlier alluded, we will be using the questionnaire we developed from a small survey. The survey was a quick survey meant to identify factors associated with hemoglobin levels among medical students in Ahmadu Bello University, Nigeria. Specifically in this quick survey, we looked at factors such as age and gender. Here, the questionnaire has just three variables: age, gender, as well as hemoglobin level. In this research, we are trying to see whether hemoglobin levels among students is dependent on their age or gender. And to say this in another way, whether age or gender are factors that affect hemoglobin level. So the dependent variable here is hemoglobin level, and the independent variables are age and gender. Let's just pause here for a second, right? Let's consider variables as just containers, okay? These containers can be used to store data on what we want to measure. Now, since we have three variables in this research, so it's like we have three containers, okay? And we took these three containers to the classrooms to look for medical students and to collect data from them. So we have the first container called age, the second container called gender, and then the third container called hemoglobin level. Now, why am I calling these containers? Well, this is so that you understand what variables are and how SPSS software also views them. In fact, most other software view variables this way. So the first container is going to contain the data for age, right? So, but before we start putting the students' ages inside this container, we want to make sure that the right data goes into the container, right? So we will need to define what kind of data we are going to collect with this container. And these definitions are called variable characteristics. So enough of all these analogies, right? Let's get into business. Now we go to the variable view to be able to enter the variable as well as its characteristics. Okay, you can see all the variable characteristics that we need to define in the variable view: name, type, width, decimal, and the rest, right? The different variable characteristics that you see here are meant to help you define the variable correctly and the kind of data that is going to accept. So we are going to look at that as we go along. So for the first variable, which is age, we are just going to write the name in the name column as age. Okay, now this name column only accepts letters and numbers, but you cannot start with a number and you cannot use any special characters. You also can't put a space. The only special character that is allowed is the underscore, and it's best to keep it simple and straight. The second column is the type, but notice that by the time you click off the name column, you have all the remaining characteristics populated by default, right? Here, the software is trying to be smart and it wants to make your work easier. So it's left for you to look at the default values and see whether you want to keep them or you want to change them, all right? Do these default values suit the kind of data that you want to collect using this variable, all right? Remember, we're going to be asking them their age at last birthday, right? So for these individuals, the age is going to be a numeric variable. They're going to give us numbers. All right, so click under the type and this brings up this dialog box. All right, in this dialog box, we are going to look for numeric type among the list of types that we have in the dialog box. Okay, we can also make changes to the two next characteristics within this dialog box. All right, so instead of going outside, we can make the changes within this box. That's the width, as you can see, as well as the number of decimal places. So what does this width mean? It means the number of digits that the data has. Now we expect medical students to have all their ages in 2 digits, right? Let's say 23, 19, right? We don't expect them to have 1 digit because 1 digit will be like from 0 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we also don't expect them to have 3 digits for their age because 3 digits will be from 100 and above, right? What we expect is just 2 digits, okay? We don't also expect decimal places since we are collecting age at last birthday. Age here is going to be a whole number, right? Okay, so we are going to change the width to 2 and the decimal points to 0, all right? I hope this is clear. Good. Now, outside the dialog box, we can also change the width and the decimal places here. So you can see when we close the dialog box, we can change the width and the decimal place. The next thing we're going to do is to put a label on this. We need to put a label on this, right? So this label column just explains the variable a little bit more. It gives you a chance to write in full what the variable is. Here there are no restrictions, so you can write whatever you like. So I'm just going to write age of respondent. Okay, note that what you write here is what's going to show on the tables and charts, so it's good for you to write a good description. Okay, it's also not a compulsory field, so you can leave it blank if you want. The values column here means whether you want to represent the original data values with other numbers. But already our data values are numbers, so I'm going to leave it as none. All right. As for the missing column, we don't expect any missing values, so I'm going to leave it also as none. In some other research, the researchers designate a value for missing. All right, so you see other research where the researchers say 97 is missing, 99 is missing, or whatever. All right, the columns here means the width of the column where you want the data to enter, and that's going to reflect on the data view. So it's okay to just leave the default as 8. All right, because our data here is only going to have 2 digits. Remember, the age has just 2 digits, right? So a column that can take 8 digits is even an overkill, but no harm in leaving the default. So we can leave the default as that. For the alignment, it is okay to leave it also by default, but you should know that numeric variables are normally aligned to the right, while non-numeric variables like string variables are aligned to the left. All right, you can change it if you want. You can put right, left, center. All right, but this is just all about aesthetics, how you want the data set to look like. All right, when you've entered the data into it. All right, next off is the measure. All right, and these particular characteristics help you to define the variable and to define how this variable was measured. All right, was it measured as a scale, meaning it was measured in numeric terms, or was it measured as a non-numeric value, which may either be ordinal or nominal? Well, for age, I hate to break it to you that it was a numeric variable, and so we'll just select scale. All right. The last characteristics for us to put up is called role, and what the role means here simply is that what role is this particular variable going to play in the analysis? What role is age going to play in this analysis? Well, in we are the one defining this, so it's going to play a role as an independent variable. In other words, an input variable. Or is it going to play the role as a dependent variable? In other words, a target variable. So if you remember in our survey, we said the age and gender are independent variables, and the hemoglobin level is dependent on the age and gender of the medical students. So age is an input variable. We will quickly do the same thing for gender. Okay, so we enter the name as gender. The type this time is not numeric, so we are going to change it to string. String here means alphanumeric. It can contain alphabets and numbers. In our case, we'll be writing male, female. When we ask the students, and we can see gender is female, right? So we'll write female or male, and so that means a string. Here, the width will indicate the number of characters. The software also uses bytes in the dialog box that shows up, all right? But it's okay for us to leave the default value as 8 because the longest element that we'll write is female. And female, the last time I checked, female is 6 characters, right? F-E-M-A-L-E, yeah. So, okay. Let's change the width to 6, all right? So, and gender should not have any decimal places. So we'll leave that as 0 because we can't be having female 0.5 or male 0.9 or male 0.6. Doesn't make any sense, right? So for the label, we'll just put the full name of the variable as gender of the respondents. I think we're going pretty well. All right, we're not placing numerical values for males or females, so we're just going to leave the values as none. And we're not leaving any space for missing, so we're also going to leave it as none. Awesome, right? Alignment by default is on the left. Since our variables is a string, we're going to leave the alignment as it is. We'll be entering words like male and female. Our measure here is not scale because a scale is for numeric values, like I said earlier. So it's either ordinal or nominal. Let's think about this for a while. The difference between ordinal and nominal is that for ordinal, the categories of the variable follows a particular order, right? While for nominal, there's no order whatsoever. So for gender, our variable has just 2 categories, right? Male and female. Let me ask you, does this have any particular order? Well, the answer is no. So male can come before female. And so for this gender, we're going to select nominal, right, for gender, because male can come before female, female can come before male. We're going to put up nominal as this. There's no particular order, all right? Male is not higher than female, or female is not higher than male. And finally, we're going to select input here for the same reason as age. Gender is an independent variable. So the last one we're going to be doing now is the hemoglobin level. So you can see we can use underscore to separate HB from level, but a space or any other special character will definitely not work, all right? So we say it's numeric, and because the hemoglobinometer we are using reports the hemoglobin level to 1 decimal place, we'll be getting readings like 10.2 grams per dl or 13.9 grams per dl. So that's how many digits? 3 digits, right? Okay, so just 3. So we set the width at 3, and because 10.2 is 3 digits, right? Okay, how many decimals? 1 decimal place. All right, so we'll put 1 decimal place. We'll write the name in full. There are no values, no missing. We'll leave the alignment right by default. For measure, this is a scale variable because it's numeric, right? So we're going to leave it as scale. And this time it's a target variable. Remember, we said the hemoglobin is dependent on age and gender. So now that we have set up all our variables, it's now time for us to enter data, right? I know that's what most of you have been waiting for. But before then, it's really necessary to save. So, and there are several ways in which you can save with SPSS. One easy way is just to click on the save icon over there at the top, and then give your file a name. For me, I'm just going to save mine as survey data set and then click on save. Okay, it's really important that you save so you don't lose your hard work. All right, next is data entry, and I'm sure a lot of you people are following along. So we use the mobile phone to collect this data electronically, so we have that data already, but I want to use this questionnaire to show you how to enter data manually, because for some beginners, they still collect data for some reason. They still collect data with paper and have to come to enter it manually. But if you want to learn how to build an electronic questionnaire for easy data collection, check out my awesome viral videos here, and I will have a link in the description below. Okay, for us to enter data manually, we will go to the data view, right? And you just click on data view below here. You will notice in the data view that the variables that we set up are arranged in column. All right, you see them in column. Each row is considered a single individual, and we record his or her age, gender, and hemoglobin level on that row. So if we have 20 individuals, we should have 20 rows, right? Yeah. So we begin from the questionnaire. The first person was 18 years of age. He was male, and he had a HB level of 10.5 grams per dl. Oh, that's quite low, man. This dude has been starving in medical school. All right. The second person is 20 years of age. She's female with a hemoglobin level of 9.6 grams per dl. So we'll quickly populate this. And then we'll come to data analysis. Well, after doing all that, it's time for us to do data analysis. All right. For data analysis, it is pretty much a very simple task. All right, and I'm sure this is what we have all been waiting for, as everything you need to do is within one single tab on the menu bar, which is the Analyze tab. All right, so the first thing we need to do is to summarize the data by variables. There's no better way to do this than to find their frequencies and corresponding percentages for the data elements or its attributes, right? So how do we run frequencies? To run frequencies, we will just click on Analyze, then Descriptive Statistics, and then Frequencies. All right, this frequency dialog box will show up. All right, so when this pops up, in the dialog box, you will see all the variables that you have in your data set, right? You see that on the left pane. Now, any variable in which you want to run its frequencies, you just need to move it to the right pane and then click OK. All right. And if you do this, you see an amazing results, right? Very, very amazing. Awesome. Super awesome. All right. But let's close this. Let's see that again with gender. All right. So we click Analyze, Descriptive Statistics, Frequencies, and then we move gender into that box and then we click OK. Okie dokie, right? All right, so let's interpret this. How can we interpret this? We can see 20 responses that are valid, right? 0 missing, okay? Then we go to down to the main table and we see that we have females with a frequency of 9 and we see males with a frequency of 11, all right? A total of 20. Awesome. We can also see their corresponding percentages. 45% female, 55% male, and since we don't have any missing values, the valid percent will be the same. Okay, this is like easy peasy, lemon squeezy, right? Okay, alrighty, let me show you some more stuff. Let's do multiple now instead of doing this one by one. All right, so we just go to Analyze, Descriptive Statistics, Frequencies, and then move all of them into there and then click OK. We'll first look at the mini summary, and the mini summary is telling us that it had 20 responses for gender and no missing. It had 20 for age and hemoglobin each, right? And no missing too. So then we're going to look at the individual frequency tables when we go down. And you can see that gender, age, and hemoglobin tables are all arranged in that order. You can also save your results to see that later. So click on Save and give it a name, all right? I'm just going to call it Results Survey and then click Save. Okay, we can close this now. All right, so this is how to do basic analysis, but there's a problem. There's a big problem with our analysis. What do you think? All right, because if you look closely, you will notice that age and hemoglobin are numeric variables. Aha! Frequency is not a good summary measure for numeric variables. In fact, for numeric variables, we will need at least one measure of central tendency and its corresponding measure of dispersion. All right, so you need to remember your basic statistics. All right. So how do we do this? Again, it's easy peasy, all right? So we go again to Analyze, Descriptive Statistics, Frequencies. Now, let's return all these variables back. Let's just return them back. Now, let's put in hemoglobin alone. So hemoglobin is our dependent variable, right? All right, so this time, instead of clicking OK, we'll click over there, Statistics, all right? This is where it gets super interesting. Wow, so you can see where it says central tendency. All right, so let's just select all the measures here: mean, median, mode, sum. Whoa, sum is not a measure of central tendency. I don't know what the SPSS guys are doing. All right, sum is not a measure of central tendency, but we're going to select sum. See where it says dispersion, right? Let's select also standard deviation, variance, range, minimum, maximum, standard error of mean. This is crazy, man. There are a lot of cool stuff here. Then click continue. You can see the mean, standard error, the mean, the median, the mode, the standard deviation, the variance, and a lot of others, man. Ain't that awesome? Well, when you go down, you can also see the frequency tables, and this is fantastic, man. So fantastic. Now, I want to ask you a simple question, and I want you all to put your responses in the comments below. Please do not ignore this, because this will determine whether I make a video on this or not. So I want to see your responses. All right, so look at the data. Our mean is 11.98. Our median is 10.90. Our mode is 10.90. Which is the best measure of central tendency to represent the hemoglobin data, and why? And please don't look at other people's comments. You need to be truthful here. All right. So, but there's still a problem, right? There's still a small problem. Well, I think it's a big problem. How can we do a beautiful research like this without charts, right? So let's add a chart quickly, very quickly. Let's add a chart. How can we do this again? Here we go again. We're just going to say Analyze, Descriptive Statistics, and then Frequencies. But this time, we're going to click on Charts in the dialog box there. Yeah, and see, you can draw a lot of charts. You can draw bar charts, pie charts, and even histograms, right? But since we're dealing with a numeric variable here, hemoglobin, right, we have to construct a histogram. I hope you're not planning to draw a bar chart for a numeric variable. So we select histograms, and we can even ask it to put up a normal curve. Woohoo! All right, awesome. So click on continue. Let's see. Wow, this is lovely. I wish I could see your own beautiful charts too for those that are following along. But this brings us to the end of this amazing, real practical, research-oriented SPSS tutorials for beginners. So in these tutorials, I have showed you the SPSS graphical user interface, how to create variables in SPSS, how to manually enter data, how to run some basic analysis, and how to draw some charts, and finally how to save. Okay, we have successfully moved you from 0 to hero in SPSS in 20 minutes. In my next video, God willing, I am going to show you how to do advanced data entry with SPSS using different variable types. Now, if you found this video helpful, please give this video a thumbs up and share it with your colleagues so as to help them improve in their research and data analytics skills. And if you want to see more videos like this in the nearest future, hit the subscribe button and select all notifications. This way, you will get a notification anytime I drop my new amazing content like this. And believe me, I will be dropping a lot of good stuff, God willing. Also, you can check out my other 2 channels where I also have a lot of amazing content dropping very regularly. And lastly, if you want to see me create any other SPSS videos like this in future, leave a comment below and I will add it to the list of my videos to make. Alrighty, that's all I have for you today, folks, and I hope you enjoyed every bit of it. I hope to see you in my next video, but until then, peace.